So you can see from this SPSS space that I have copied. You can simply copy the data from Excel or any other source, and you can paste it in a very old-fashioned form in SPSS space. But the problem is that, or not a problem, but the thing which you should be very careful about is that there are two tabs here, the variable view and the data view. The data view is very visible, but in a nice, if you want to do a good research, I suggest you that don't call them 1, 2, 3, 4. Give them some names. So for instance, if you see the original data, it's about, the thing I want to test in this original data is that it's again from the financial side, because that is my field. So I'm more comfortable with the financial examples. That the company's revenue is there. Revenue means the total sales revenue, how much money you get by selling goods. The price to earning ratio is that how much you invest and how much you get from the company. That is called price to earning ratio, right? Operating profit is the profit which come from company's operations. For example, Microsoft profit, operating profit is how much money they get by selling all the softwares. BP's profit is how much profit they get after selling all the oil products. So that is the operating profit. If you get some extra money from interest by investing in some other companies, that's not operating profit, because that's not your main business. If I'm an investor and I want to invest in BP, I invest in BP because they are oil explorers. But if BP has some surplus money and they invest in Marks and Spencer, that's not my purpose of investing in BP. Hence, the profit which BP gets from Marks and Spencer and show in its own profit, that is not operating profit. All right. Average market operating returns, that's market returns, yeah. Debt to equity, how much company's debt and how much is the equity. Innovativeness, how innovative, how active is the company when it comes to spending in innovativeness. And you can see that some variables we are not able to quantify. All right. In that case, we can convert the qualitative. We bring some qualitative variable into quantitative analysis. And you can see there, here I'm using only 1 and zeros. You get my point? So we use the binary variables. I hope you understand the word binary. All the computer languages are in 0 and 1s. That's the way you write your algorithm. Sorry. So that's binary. We also call them qualitative variables. We also call them dichotomous variable. It's a dichotomy, 0 this way or that way, 0 or 1, black and white. This is a time to have a stopover and discuss something else with you as well. Variable can have different measures. Now, just I know that what could be the other measures of innovativeness. I must tell you that I have at least 5 theses, my students at both master's and bachelor level, who are researching on innovativeness, how the company's financial performance is depending on innovativeness. And in this innovativeness, we are not using this measure. This point just struck me. In this data, I'm using innovativeness as a binary variable. Binary means you do it 1, you don't do it 0. But I have, the variable is same, innovativeness, but these days I'm more obsessed or more impressed with the other measures. The one measure which I use, sorry, for innovativeness is that R&D expenses divided by total revenue. And the second variable which I use quite often is the ratio of intangible assets to total assets. You get my point? R&D ratio, R&D expenses to sales ratio. So out of your total revenue, how much money you spend on R&D? Larger you spend, more innovative you are. And on the other side, the ratio of intellectual assets or the intangible assets to total assets. Okay. Yeah, so I was discussing with you the concept of innovativeness. You don't have to learn this, but the message I'm trying to give you is that the same variable could be proxied by different measures. So one variable could be that you are using binary, one measure, but the others could be that you are taking ratios, or like I remember once we discussed that how can you measure the concept of welfare? Welfare can be measured by many ways, and so is innovativeness. The next variable which I designed is the closing price of the stock, how much return you get, and so on and so forth. So there are some more variables, but that's not the point. The point is that before you are going for actual calculation, you need to be aware of your hypothesis. I hope you understand hypothesis by now. Okay, Salman discussed with you, and I think I also discussed from time to time. So can somebody tell me what exactly is, what do you mean by hypothesis, and what type of hypothesis do we use in empirical research?
It's like
if you see this question, this example, if you look at the G variable, is it same in SPSS as well? Okay, first of all, let's give them some names. Not these will not be the real names. You can use some abbreviation. F G H I J. Yeah. So let's assume that our G variable, which is the firm's adjusted stock price, is a dependent variable. So it means that I can call Y is equal to alpha plus beta 1. And let's call our first variable is A plus beta 2 B. Sorry, then your Y variable would be actually dependent variable would be G variable. I can call it G. G is your dependent variable. Beta 3 C, beta 4 D plus beta 5 E, beta 6 F, and G is a dependent variable, so this will not come here, and beta 7 H plus beta 8. Do we have more variables? We have two more variables, I and J. Yeah. So beta 8 I. J. Yeah. J. So basically, I'm trying to say that there is a variable which depends upon several independent variables. Okay. It's not always one variable affecting the other variable. There could be the multiple variables also. Like, for example, if I ask you that what factors can affect intelligence? Well, intelligence depends upon your upbringing. Intelligence depends upon your quality of schooling. Intelligence depends upon even the education of your parents, because the way you're brought up in the childhood. Intelligence depends upon what type of society you live in. There's several factors which can contribute to the intelligence. Now, the problem here is that some of them you can recognize, some of them you can't. It's very hard to say that you can list all the 1,034 variables which can affect intelligence. It's not possible, right? But you can bring some of them. The question is, who you bring? Is it that you toss and then you decide? No, they come from your theoretical and empirical review of literature. That is why we form our models of analysis after we have done review of literature. Sometimes the literature is available and there's no problem. You can form you can make your model very clearly. But sometimes you have to make some assumptions, right? Remember I discussed with you that what is the difference between hypothesis, assumptions, and even perceptions. Even misgivings, even some kind of, how to say that? Yeah, some kind of, we make some kind of imagination before we start doing research. Even in sciences, where the outcome is not seen before, you make some kind of sample space that, hey, the outcome will be one of them. If you throw a dice, you don't know which phase will show up, but you know for sure that it will be between 1 to 6. It can't be 0 and 7. So you know for sure that you don't know exactly the exact outcome, but you can make some educated guess about the probable outcome. This educated guess about the probable outcome is called hypothesis. All right, and it starts at the end of review of literature and before you do the data analysis. And if you see all the papers you have chosen, you will find that hypotheses are formed almost at the end of your review of literature chapter, or at least at the end of the sections within the review of literature section. Agree or not? Sometimes there are some theories which help you to make hypothesis. Sometimes there's no theory, but some people have attempted to do the same kind of research before. So that finding can act as a, like a baton. I think I gave you example of relay race when you give the baton to your fellow athletes and so on. So that's something which you borrow from your predecessors, research predecessors, okay? Now, the hypothesis is clear, I think, yeah? Now the hypothesis that we use are of two types. The one is null hypothesis, and the other is alternative hypothesis, yeah? You know them? The null hypothesis is based on a philosophy called a person is innocent until proved guilty, which means that we always go for the rejection of a phenomena. Let me put it in simple words. If I have two groups of employees, on this side of the table, they get some special training. And the other side of the table, they don't get any training. And I check their productivity after some time, after they have been trained and they have not been trained. My purpose of this research would be that does training makes any difference, right? My null hypothesis would be that there is no difference in the productivity of employees, those who get training and those who don't get any training. Are you with me? Look, I'm giving a big statement. My null hypothesis would be that the employees, those who get training, their productivity is not significantly different from those who have not got the training. So I'm always going for rejection. This is called null hypothesis. So in this case, my null hypothesis would be that all my coefficients, beta 1, beta 2, beta 3, these are the regression coefficients. And okay, you don't have to worry. SPSS would give you them. Okay, don't worry about that. Beta 4, and so on, beta 9, they all are equal to 0. It means that innovativeness, operating profit, firm's stock return, the firm's debt, equity, whatever those variables are, you don't have to worry because they would change, depending upon your interest. They have no impact on the company's stock price. Or if I say that, I use the previous example, intelligence depends upon many factors. So you can say that the family background, the level of education, the quality of education, the societal background, your upbringing have no impact on intelligence. All right. So the hypothesis which we are going for rejection is called null hypothesis. Make sense? The second hypothesis is H1, H subscript 1 is called alternative hypothesis. The alternative hypothesis is what I mean. That does, for example, in this case, my alternative hypothesis could be that those students, those employees who get training, they overperform their colleagues who have no training. You get my point? That those employees who get the training have better performance than those who have not got the training. This is my alternative hypothesis. And here, again, there's a catch. The catch is that so it means that my alternative hypothesis, if I explain in the same betas, if I rewrite them, beta 1, beta 2, they are not equal to 0. So they are not equal to 0, okay? So they have some impact. The question is, the impact could be positive, the impact could be negative, or both. If you want to see if there is a phenomena, if there is a cause variable, the cause variable is so that it can have both positive and negative impact, then your hypothesis is two-tailed. It has two tails. Remember this kind of picture? I quickly draw here. This is the center. If I want to check at 5% level of significance, then 2.5% on this side, 2.5% on this side. Right? If you're so complicated to explain it. If you're finding, if your result is within this range, then the difference is not significant. Look, this is the average. The center is the average, yeah? If we have the perfect utopian data with perfect symmetry, no deviation, then the value of your outcome would be this. But the fact is that there will be some deviation. Question is that how far you can tolerate the deviation. If I take 5% level of, I think I explained it last time. 5% level of significance means that I can tolerate 5% fluctuation, right? And if it's two-tailed test, two-tailed mean I give them training, you don't get training. Training can make them better. Hey, training can make them worse also. Maybe I gave them wrong training. So when I say after training, the performance is different from you guys, it means that it can be better than you or even worse than you. So I'm considering both sides. Positive impact, negative impact. In that case, the hypothesis is too big. And then I run the regression or any tool, and I get the finding, and imagine that my finding is in this range, this shaded range. And because my level of tolerance is 5%, I can split evenly 2.5% on both sides. If the output, if the result, and what's my null hypothesis? My null hypothesis is beta 0. Here is beta 0. But beta can be a little bit plus, a little bit minus. But as long as this plus and minus is within the limit, I would say my null hypothesis is valid, and I reject my alternative hypothesis. It means that training and no training makes no difference, right? Training or no training makes no difference. Because even if there's a difference, look, if I go exactly beta 0, which means absolutely no impact of training, then beta should be 0 here. But even if beta is a little bit plus or minus, but within the range, I say I accept H0, reject H1. But if my beta is going this way and this way, then the beta size, am I recording it? Then beta size, I quickly recap what I said, that once you have your hypothesis, then you draw on the normal distribution curve. Your null hypothesis could be of two types. It can be two-tailed or one-tailed. In case of two-tailed, as we discussed that does training make any difference? Well, training can make you better or worse. In that case, I'm considering two-tailed test. And in that case, I can split this 5% level of significance as 2.5% on both sides. And if the actual statistic, if the sample statistic is within the range of this shaded part, then your null hypothesis is accepted. The difference is there, but difference is not significant enough to make a claim. You know, I think I gave you example that if you're a cop and you bring a case and you say that, hey, the inspector is saying, the chief, that I think this person is criminal. And then the chief is investigating that, hey, can you say with 95% confidence that he is a criminal? He committed the crime. And then you say, I think when you start fumbling and murmuring, means that maybe something is wrong with your claim. All right. And then we give the benefit of doubt to the who? We always give benefit of doubt to accused. We don't hang somebody because we suspect. Well, in democracies, it doesn't happen. But if there is a problem, if there's a confusion, if there's a doubt, we always give doubt to the accused before we make him culprit. Okay, this is how the system. So that also works according to the statistical significance rule. Okay. Your training, if I'm only studying that training is making you better, then I'm considering one-tailed test. Okay. If my hypothesis is that training makes you better, then the picture would look like this. It means your hypothesis is this side. And then all the 5%, because now we're not considering the downside of training, we're not considering the negative side of the training, hence all the 5% will be on this side. Because it's on the positive side, yeah? Look at my hypothesis. Training makes you better, positive, favorable. So that's why we are on the positive side. Okay, if my hypothesis is that education reduces crime rate, so more education, low crime rate. I'm not saying education education may increase crime or decrease crime, both ways. No, I'm saying education decreases the crime, then my hypothesis would be on the left tailed with all the 5% here. In that case, your hypothesis become one-tailed or two-tailed. So it depends on you. That do you have enough evidence? Like for example, I can show you one of the papers. Do we have any other names for dependent variable and independent variables? Dependent variable is also called explained variable, and independent variable is also called explanatory variable. I can write it down. Dependent variable is also called explained variable. And all these independents are called explanatory variables. So explained and explanatory variables. Okay, but that's not the point. The point I want to prove here is that if you look at the signs of these hypotheses, these are the hypotheses. The signs could be negative, positive, negative, positive. When there is only one sign, all right, it means the hypothesis is one-tailed. But here, there's both positive and negative. It means that the promoter director's proportion, you don't have to worry what this is, but this variable could have both favorable and unfavorable impact on the dependent variable. Can you give me some examples of variables? We just discussed training can be good training, but it can also backfire and also have a negative impact. Sometimes training doesn't work. You think that your neighboring company have done the same training, same courses, and their success rate is high. And you want to do the same training for your own employees without considering your corporate culture and your institutional system, and the same training can backfire on you, can have a negative impact on you. You get my point? Can you give me some more examples where some cause can have both positive and negative impact on the explained variable? Yes.
Like when you are doing advertisement and thinking that advertisement will uprise your
very good point.
Your
yes.
Sales.
Could be positive, could be negative. If you are a good thinker, now you can say that, hey, these things you do before you do the empirical research. Remember, these things are done before the data is analyzed. Okay, but as a good planner, you also see the downside of the business. So when you are giving a presentation in the board of directors, and you are giving this statement that, hey, you know what, this kind of advertisement campaign will push our profits from millions to billions, then somebody should question you, some senior board member, that, hey, do you see any negative impact of this advertisement campaign? All right. If you don't have a point, then that guy, that old experienced person would tell you that, hey, this advertisement campaign have also can have the negative impacts also. So please consider the other side of the picture also. Corporate campaigns are not political campaigns. In the political campaigns, we always talk about the goody things, say we will change the world and blah, blah, blah. But in the corporate actions, you should see the upside, but you also protect your backside, the downside also. The downside is very, very important to hedge, to protect. That the same action can cause good impact, but there could be a possibility that it can actually, rebound on you. Boomerang effect, we call it. Boomerang? You throw and it comes back on you. Yeah. So the point I'm trying to make is that we can have both positive and negative sides. So this is a two-tailed hypothesis here. Yeah. My question to you: when you study literature very extensively, you can understand that this variable has a positive impact. Most of the studies say that advertisement makes positive impact on sales. So sign is positive. You can also study in the literature that if a company is is increasing its wastage. If a company has lots of unsold goods, let's say you make production, but people are not buying from you. So your inventory, your stock is rising. It can have a negative impact. So the hypothesis is negative. You can also have some positive and negative both, whereby you say that something can be positive and something can be negative, as gentlemen gave the example of advertisement. Can you have a fourth option? Can you have a fourth option? And what could be the fourth option, by the way? You can have a positive, you can have a negative, you can have positive and negative both. Nothing, exactly. There is no enough evidence. You tried your best, but you could not find. Your review of literature is inconclusive. You need courage to confess it. That we try to read the literature, we try to explore the literature. Unfortunately, we can't really make any hypothesis. Okay, so that is when we are unable to make any hypothesis. Have you seen any example in the literature where you could see there is no assumption about hypothesis or something? Have you seen any? Yes or no?